So we got kind of a neat project here today. Hopefully everybody else thinks it's as neat as I do. So I've got this cylinder right here. I got it all set up in the forge already. And of course I'm using my American Toolworks company lathe. It's got a 10-foot bed, which is one of the only reasons I can do what I'm doing. I got the forge jaw chuck, and I'm holding the eye of this loader steering cylinder tube. This is off a John Deere loader, and comes out here. I got my steady rest in place. Pretty excited to use this. First time I've gotten it out since getting this lathe. And the problem here is the cylinder's leaking. And as you can see, if you look closely, the cylinder tube is belled out. So obviously I had too much pressure, belled this out. And inside, where it's belled out, is right here. That's where the O-ring on the gland seals. So you can see the next step in is where the piston actually rides, and that seems to be true for dimension. But where the gland seals is leaking because it's belled out and the O-ring doesn't get a good fit anymore. Ordinarily, I would either make a whole new tube, or I would cut the collar off back behind the bell and make a new thread with step down for O-ring welded onto the tube. But this is a rush job. It's a Saturday. I'm usually not in the shop on today, but it's for a good buddy I do a lot of work for, and he's in a real pinch, needs to get this thing back up and running. And because the O-ring here isn't moving, it's a static O-ring just holding the gland, what we're going to do is we're going to weld up the bore and recut it back to dimension so that the O-ring will be able to seal again. The threads, surprisingly, are actually in pretty good shape, and I think if you look at it, I think the last couple are a little stretched, but the mouth, up about 3/4 of them are pretty good, and the last couple aren't even that bad. So I think, the last couple are barely stretched out, but they're good enough to hold the gland for this job. So ordinarily, I'll weld on something like this, I'll weld it up and return it, which is what we're going to do. But I came up with a setup which I am very excited about, and you'll either think I'm an idiot or you'll also be excited about this. So what's going on here, if you're wondering, this is my robotic bore welder that I use for line boring. And I have it hooked up to my MIG welder in the shop here. And this probably only works because I got a 10-foot bed on the lathe. But I made myself a new post, which I can put into my tool post. This is kind of the first design. I'll make something a little nicer. But I was able to put my robotic welder in here, so rather than hand welding, because if you've ever hand welded this stuff, when you start going round and round and round, you're using one hand trying to turn this, and it can be pretty stiff to turn, and it's really tricky to one-handedly keep this moving smoothly while running a MIG welder with the other hand trying to get even bead. So I thought, I have a machine for doing this. When you robotically weld, you get a very, very even pass. If I turn the rotation on, you can see this spins around and lays an even bead. And I can stop it wherever, and it automatically steps back on its own. So you have an even step, you have an even pass, and you have an even thickness. It really makes for a very good finished product. It's how you can get a welded and recut bore done with no voids. So on here, the key thing is we're going to stop short of the threads. The O-ring seals fairly far in, so if we end up stopping just a hair short, I'll be okay with that. It's already chamfered to let the seals in. If the edge shows, as long as it's smooth, we'll be fine. If I screw up the threads, we'll have issues. So I'm going to err on the side of stopping a hair early. But we'll weld from right in here, right on out, and then we'll come on out. I got my boring bar all set up. This is a pretty meaty one I got with the lathe. I think that's, I haven't measured it, it's got to be somewhere around 2-inch square. I just have a regular cutter stuffed in there. So this should work pretty nice. We'll weld it and bore it, and if you like what you see, subscribe, like, leave me some comments. If you need some weird work like this done, let me know. I specialize in working on, well, mostly old junk, but I'll make whole new tubes for these, and I'm sure I'll film a few of those. See how well this works? I've got a welding hood over the camera. So hopefully you'll be able to see what I do. Since I'm using my older hood, hopefully I'll be able to see well enough to do a good job. Like you can see it, that's cool. We're back. I got the welder taken off and we got the boring bar hooked up, and we're gonna start cutting this. Really don't want to overshoot. Then we have to bubble it. Got enough to take a measure, see how we're doing. We're shooting for between 3.935 and 3.938 inches. That's specs on the O-rings. Look those up. Based on O-ring groove and O-ring that was in there. And we are 3.9. Well, we gotta put a little more weld in because we're at 3.9195 and we're not cleaned up yet. I was worried it'd be belled out too much. And it is. So we got our first pass done, and I just stuck a new cutter in. We're all screwed up here, and we're going to start cutting for dimension. But it's a nice solid weld. I don't see any holes or pock marks or anything. 3.876. Okay, that's where I thought I was going to be. So we have another 63 left to go. check before we go too far. This first part of the lip here is before the O-ring, so if I actually screwed it up, it would still be okay. 3.896. So that's pretty darn close here. Threads in. Really don't want to overshoot this, and we're darn close. About 924, I think. That's what that is. Yeah. Run the feed both ways on here. This should be our final pass. 3/1000ths to give us a total of 6. Give us there and we'll spring pass out. Good finish. Measured. We've got our dimensions nice. We set our cutter back. We cut a little bit of a angle on this corner here so we don't cut our O-ring going in, just because the weld's it's not a perfectly smooth edge from the weld. And I think we'll be ready to put it together. Clear all the overhangs. I'm just going to hit that quick with a little buffer. Just a flapper wheel, buff it up a little bit. Just to make sure that corner is nice and smooth. It doesn't seal, it just can't cut a seal if it's not right. So, hopefully I got enough air. I got the power switched over to the lathe right now. test fit our gland. That's threading in there nicely. Not binding. Well, there she is. I'll put this thing together, and if you like my video, subscribe, like it, leave a comment. If you want to see some more, I was pretty happy on this video to get out my bore welder. Well, that takes care of the machining portion of this. I'll put it together real quick, and hopefully you want to see that. But if you like my videos, like, subscribe, leave comments. I was really excited to get out the floor welder. I usually use that for line boring, but I figured it's got to be a good way to hook it up here and make this life easier. It does the same thing, it's filling up a hole. And it's nice getting out this baby here. I've been hoping to get one for quite a while, and when this was with this lathe, I was very excited. There's also a bigger steady rest. Looks kind of homemade. I think it uses the same base plate because I don't have a second one, and it doesn't have the blocks in it, but the whole frame's there with a hinge, and there's a third one which is pretty darn scabbed together. I'm not sure that's worthwhile, but it all came with the lathe when I got it. But this one, I think it might even be original. I gotta look through the brochures. I found a couple brochures online, but the paint color matches, so maybe it fits just right. So I'm very, very pleased with the way this came out. I think someone modified it to put the ball bearing rollers in here. These blocks look like they've been machined much more recently than the rest of it, but we'll get this thing put together, and hope you enjoy it, and keep watching my videos, subscribe, and have a good time. Start by just dumping it out. We'll get this all washed up, and I'll show you how to put it together. So I got tube and a pipe vise. It's cleaned out, and we're going to put it together. So one trick I like to do, which I learned a long time ago, putting these together, use a little bit of grease. This is just regular grease, and a little bit in the threads. It kind of fills the base of the threads up, and it prevents you from cutting a seal on them if you brush past them. This cylinder, the threads are set back, so it's not as big a deal. Some of them you have the O-rings ride right across them, but a little bit of lube in there tends to help just get everything going. And I really want to get some grease up right where that O-ring steps up onto that bore we just cut. I did relieve the edge a little bit and polished it, but I want to give it every advantage I can because I don't want to have a cut O-ring and have to open it back up. So we're going to lube up the edges. And now, this is pretty heavy. It's a 3.5-inch solid rod. It's single acting, so all you have is a wear band. And then we've got the gland that we just put together. And that nut is Loctite on. So, get this threaded in here. The packing in the gland here, it's just a U-seal or a version of one. They're a little bit tight when you first put them in, so the rod's gonna need to get pushed through it. But for starters, get it threaded. Got a hook spanner. It definitely feels like we got the O-ring engaged. That 3/4 inch gap here, that's when the O-ring started on that surface we just machined. It feels like we're pushing it. Careful on this table, I got a rather large transmission over there. Not sure the table likes the weight. That's why the cherry picker's still hooked to the top of it. A little bit of safety. Snug down. Alright, that's tight. And well, we're going to pressure test it anyway, so the rod's got to be out for that. Get to that port. Now we're to put our hose back on it. So the customer wouldn't be too pleased if it got it back with no hose. Just putting the hose back on it. It came with. It's a lot better to test these with hydraulic pressure, and you gotta be real careful putting air to a cylinder. If you're taking them apart, you'll shoot them all across the room. This is threaded in tight, so it's not going to shoot out. Air can be pretty violent on these. We are all the way out, so I'm not too worried about that. It's better to pressure test these or do any pressure stuff with oil as opposed to air. The liquids don't compress, and therefore you don't end up with a lot of force. If something opens up with air behind it, the air is compressed, it'll shoot like a cannon. High pressure oil isn't compressed, so if this were to blow out, it would literally go plump on the floor. I just want to make sure this O-ring's seated properly, and a little bit of air will tell me that. If the O-ring's not good, it's gonna leak, and if it is good, it should be good at a lot more pressure than this. Pretty confident it's good, but you see how it jerked pretty hard when it went? I went 1.25 inches, but we're holding, so I'm gonna call this good. We're pressure tested. The only thing we need, there's a set screw hole. This just keeps it from backing out. Goes in there, and it's behind the threads, so it can't spin its way out. So, key with the set screws, when you're taking them apart, they're usually covered in junk, because if you're taking them apart, you're replacing seals. If you're replacing seals, it's leaked, it's covered in junk. So, look for a set screw, because this one, I should have pointed out while the gland was out, there was a big set screw scratch mark. Someone tried to take this apart without taking the set screw out. Probably had a bad time. But, found my set screws, there we go. Like, subscribe, enjoy. Have a good night.